In section 2 of chapter 4, we're going to look at another method for seeing if we could find that particular ordered pair that would be a solution for our system of equations that we have here. And here we would have one solution. If the lines were parallel, there would be no solution. And if the lines were on top of each other, there would be an infinite number of solutions. So in this set, we had seen earlier that graphing sometimes can be challenging. So we're going to use algebra to solve these systems of equations. And we're going to use the principle of substitution. Now it's pretty straightforward, where if you have a series of equations and you have one equation that is solved, let's say for the letter y, we can take this value, which is what y would be, and put that into the other equation where the y is. And then we have an equation with only one letter. And we see it here. Sometimes it would be x. We say x is y minus 2. So we take the y minus 2 and put it where the x is. In a sense, substituting a value for another. So let's set it up and work them out. So I'll model this one for you. The systems are there. We're going to take again this and put it in the other equation where the y is. So it'll be x plus 2x, that is the value for y, 2x, equals 9. We get 3x equals 9, x equals 3. Now we have one of the members of our ordered pair, which is a 3. Now since we know then that x is 3, we can go into this equation and go y equals 2 times what x is, 3. Y equals 6. So there is your ordered pair. And if I were doing this on a test, I would then see if these in fact made both statements true. In MATLAB, of course, when you're doing your practice and later you quiz me, they will tell you the answers. But on a test, you want to be sure by checking. Now in this next one, you're going to take this value, which we say x is worth this, and put this where the x is. All right, we'll let you do that. So something like this, where the x is, we put the y minus 2 plus y equals 6, group like terms. I got 2x. Transpose the negative 2 to this side. 6 plus 2 is 8. Divide both sides by 2. I get y is 4. That's my first member. Now I then go x equals, my y here is 4. I get x equals 2. Again, I would take these values on a test and put them back in there to check. Now our chapter 4 test, there's only 10 questions, and you have, the 75 minutes for it. So you want to be sure you get your best score, double check your work, do it carefully. Now in example C, we note that we don't have any of our equations solved for a particular letter like x. But we can. X equals, transpose the 6y. On this side it becomes a negative 6y plus 2. Now we're going to take this, which is our value for x, and where x is, we're going to substitute, and I'll help you set it up. So it'll be 4. Now we have to put that in a parenthesis. Negative 6y plus 2 plus 5y equals a negative 11. So again, this concept of substitution, we define either our x or y equals something, and then take that value, put it into the other equation through substitution, and if it's a sum like this, we have to put it in parentheses. Now we clear parentheses, negative 24y plus 8 plus 5y equals a negative 11. We'll give you some time to finish that. Combine like terms, we get a negative 19y. Transpose our positive 8, on this side becomes a negative 8, which gives us a negative 19. Divide both sides by a negative 19, that gives us a positive 1. So our y is a positive 1. So we put it in our other equation, x equals a negative 6 times 1 plus 2, and this is a negative 6 plus 2 is a negative 4. X equals negative 4. All right. Let's see if you can do this one on your own. We're going to take this. Well, let me do the solving for x here. X will equal, transpose that, 3y plus 3. So you're going to take this and bring that where the x is. Be careful of your signs. Give you some time. So again, we're substituting, and now be careful of the signs as you do the distribution. That's a negative 15y, a negative 15, a negative 2y equals 2. We then group our like terms. We get a negative 17y. We transpose the negative 15 to this side where it becomes a positive 15. Add it together, we get a 17. We divide both sides by a negative 17. We get y equals a negative 1. So now we have one of our ordered pair members. Now we take our negative 1, put it right up there, and we can do this mentally. 3 times a negative 1 is negative 3. Negative 3 plus 3 is 0. So our ordered pair for letter D that satisfies both equations is this. If we were to have graphs, they would intersect at this point, as would this. All right, let's go on. Now, to save time, I'm not going to do every single one, but we'll look at some that are different, like in letter F. Now, you're told to do this by substitution, and there is no term that is just a plain x or y. So if you are told to do it this way, what you would need to do is divide everything here by 3. And you would get a new equation. This would be x minus y equals a negative 14. Now you could solve for x. X equals y minus 14. Now you're going to take this, and where there's an x in the other equation, you're going to substitute. So as classwork, we'll work on letter F. Okay, we've simplified this by getting just an x that we can use by dividing everything by 3. We then solved for x by transposing the y. We then substituted the x, in the other equation. There's our value of x. We distribute, and we get this. We combine like terms. 6 and 7 is 13y. Added 84 to both sides, and we got this. Divided both sides by 13, y equals 9. So we now have one of our ordered pairs. Now to save room, we can just do this. Put our y value right there, 9. 9 minus 14 is a negative 5. And if you were to put these into the original or your new equation, that would be a solution. Now, in letter G, as we look at it, it looks a little funny. Notice if you take this term and transpose it to the other side, that's going to give you x equals, and it's a negative y plus 2. Well, to get rid of the parentheses, that's going to be a negative y minus 2. That you're now going to take this, and where there is an x in the other equation, and again I would bring that over, and this would be 3x up here, minus 3y equals 30. So this x we're canceling out. So now you bring this up over in there. And we're not going to do that one with you right now, but you'll have plenty of practice. But let's look at letter H. What needs to be done here? Well, I would multiply everything by 2. So this would become x plus y equals a negative 6. You wouldn't try to do anything with fractions. And now you would say x equals a negative y, a negative 6. Take this and move that where the x is. Okay, and they're done in a similar way. What we want to stress here is the methodology of using substitution, where you solve for one letter, take that value, bring it into the other equation. Let's go. Now, in this example, again, we have to solve for y. Y will equal a negative 4x, so we transpose that, minus 11. Now we're going to take this and put it in the other equation for y. And we'll give you some time for this. And we hope you picked up on this. It's a plus 11. And when we substitute and distribute, we get a negative 12x, a positive 33. And look what happens. The 12x's cancel out, and we end up with 33 equals 33. Now, is that a true statement? Yes. we had said when you end up with a true statement, these equations are actually the same. And therefore, the answers would be whatever is for one is for the other. So there's an infinite number of answers. And just let me give you a little bit of background on this. If I were to multiply this equation by 3, this would be 12x plus 3y equals 33. So this equation and this equation are exactly the same. This one is an equivalent equation. So here we have the same equation, would have been the same graph, so an infinite number of answers. Now how about this one? Well, we want to solve this so we can do it by substitution. So here we would have to divide everything by 5. So we then get a new equation, x equals, I shouldn't say equals, but x is plus 4y equals 0. So what does x equal? X equals a negative 4y. So now let's take this value and put it in the other equation. And we'll do it together. So a negative 6 times a negative 4y minus 24y equals a negative 10. Now a negative times a negative makes this a positive 24y minus 24y equals a negative 10. Now notice these cancel out and it becomes a 0 equals a negative 10. Is that a true statement? No. And we had said when you do the work and get not a true statement, there is no solution because these lines are parallel. And if we were to fiddle with this, we'd see that this part of the equation is actually the same. This part is the different part. So, in a sense, would be parallel lines. If we solve both of these equations for y, they would have the same slope, but different y-intercepts. Okay, you'll have your practice, your quiz-mes, and again, show the work neatly and orderly so that on a test, I can give you partial credit. You may have just messed up somewhere. We want to do that.